Why this changes everything? Because it's not gas. Why it's not gas? Because water and gas have a huge difference in density. Gas would go up and only up. It would not sink down indistinguishably from water, with the same flow, up and down and up and down. If these particles follow the exactly same flow of the liquid it's in, it means they have about the same density. When atmospheric air is injected inside water with its flow and its particles, it is notorious the difference from these particles and actual gas. If it's not gas, then what is it? 1000 magnification. Pure mineral water. Refracted light only. A bubble appears and makes a graceful curve. That's not gas behavior. Gases don't plan their trajectories. Gases don't slow down and stop. Here you can see them driving in straight lines. They steer around obstacles. They even bump into others, then keep going. This is obviously not gas. Finally, sympthicone and mineral water. They move, curve, bump and park as they please. The macro view. Bubbles defying gravity, swimming through still water like gas with a will. Now the micro. Every gas has the same exact shape. Since when does gas have form? Since when does gas follow ISO 9001 standards? No camera tricks. The solids are at the bottom. Gas bubbles diving fast through dense liquid. Gases don't behave like this. That's an unaddressed problem by physics. The same dense liquid, shaken gently. Macro and micro. Bubbles diving, rising, spinning, all at once. The pattern's always the same. It doesn't matter the liquid. When bubbles appear, they follow the same ISO 9001 template. That's not gas. That's not random. The only logical conclusion. Same glass, barely tilted. Bubbles hold their shape again. One drifts gently from left to right. Same structure. Same stability. Always ISO 9001 certified. Doesn't matter how soft the movement is. They dive straight to rock bottom of classical physics. Uniformly dressed, ISO 9001. Diving in two phases, slowing down, then speeding up, into the depths of hydrocarbons. One stroke at a time. Like swimmers, they're holes in the cornerstone of modern science. Ice shatters glass and tears through metal, yet it cannot burst gas bubbles. If gas is less dense than liquid, how could gas molecules, previously dissolved in water, move in reverse, gradually finding and joining each other, forming perfect spherical structures stuck to the solid? While the plastic bottle was freezing, we activated deep research mode to understand just how intense the pressure generated by freezing water really is. When water freezes, it expands by about 9% in volume. If that volume has nowhere to go, internal pressure can exceed 300 MPa, equals 3,000 times atmospheric pressure. More pressure than a submarine withstands at the bottom of the ocean. However, in the plastic bottle, the water froze completely, without damaging the bubbling structures of the gas. Finally, the before and after of the microscopy. Before, internal structures incompatible with gas bubbles. After, the structures inside the bubbles broke. Are we going to accept that it is possible to break a gas